Hi. So we start today with a quiz. We had a little quiz last time, right? Let us start with it. So we worked on exercise 22 that is dealing with function cosine. And all we needed to know about that is that the basic wave of function cosine starts someplace on the y-axis and it ends at the same exact level. Now the place will be a 2 because it looks like the amplitude here will be a number 2, so will vary from negative to positive 2. Also, pi over 2 times x is going to be in between of a 0 and 2 pi. That's standard period for function cosine 2 pi, but we need to make sure that we'll pull out x. So I put 2 over pi multiplied by each portion of this inequality. So inequality sign stays unchanged. And also we have x isolated in the middle. The pi and pi will cancel and leave us with 4. So our end of this graph or period will be 4, just like that. So once I have a picture, then it starts to make sense to find its matching graph, and looks like they all have a negative and positive 2 along y-axis. So I just need to make sure that 4 is present and it's not in the first row, and I can see 4 someplace here for the graph that starts up here at 2 and ends at 4, just like that. So this is my exercise 22. So it looks like letter E is what we have corresponding to it. So if someone wants to try another exercise, you're welcome to do this over weekend. Just email me your answer and make sure that you clearly say what you are trying to do, right? Because I'm aware of this exercise, but if you say do problem 29, then it's a good idea that you put a picture so I can understand what is going on, right? So you could have extra credit if you want. That's always a good idea. Or if you're fine with your performance, you don't have to. So it's really up to you. So we used to graph sines and cosines in that section. I'd like to try one more exercise here. Let me try one with a function sine for a change. So I'm gonna pick one, or if you have one in mind, let me know which one you want me to graph. I'm gonna try 58 in the meantime. So today's goal is to keep on graphing, and to graph the exercise 58, I'm going to start with graphing function sine. So this is sine of pi over 8 times x. So I'm going to leave out the 3/2 for later and just look at graph of function sine that will start at the origin, go down, and then raise back up and stop at some place. So since it's a negative 1/2, then my amplitude will deal with a half and a minus 1/2, always like that. And the graph has a negative in front, so it started to go down rather than up. So now we need to decide about pi over 8 with x. So we need to get rid of this pi over 8, right? So I put this the standard way, we always do it, in between of 0 and 2 pi. So this way, we're gonna have x isolated. So I'm gonna multiply it by 8 over pi, right? So it's always a reciprocal, 8 over pi. So this x will be the only thing left in the middle. So when I do this, 0 will be the left side, x will be only thing on the right side because these guys, they cancel. And now pi's are gonna disappear, so we got 16. Great, I put number 16 here. So whatever is on the right side, it's gonna give us the right end of this. And now I need to use the 3/2. So now I need to bring my graph upwards by a half, and then another one, so someplace all the way here. So let me graph. So here's my scale. So now my highest part will be at the level of what? We moved it by 3 over 2. So 1, right? And then 1/2 plus 3/2 is 4/2. So that'd be 2. So I'm in between of 1 and 2, looks like. And our function, the sine function, always starts in the middle, goes down, and then returns back, and then returns to the same level. And this level is 16. So I have all the numbers that we need placed on the plane. So the key part is period, which is 16. And then you could put a little bit more of the graph if you want. So I would recommend over weekend to look at this again and maybe try another exercise like 57 or so, because this graphing story is with us from now and on. And the next section just continues with more graphing. It gives us graph of function tangent, which is a quotient of sine divided by cosine. And today I'd like to just look at the function tangent, and next time we'll look at the others. Today I just introduce you with tangent. I think that should be good enough. In fact, I just introduced you with this graph. It's here. It's on this nice figure 63. So what's important to realize about the function tangent is the fact that period is equal to pi. It's from negative to positive pi over 2. So the gap is pi, because then the graph will repeat again and again to the left and to the right. So this is a graph of function tangent. So I'd like to graph some of the tangents. I think it'd be good practice. So let me go to the exercises. And the point is that the process is all the same. And that's why we just want to, well, get used to the new function tangent graph. But other than repeating the same steps, is nothing really different. So how about 21 exercise here? It deals with a tangent of pi over 2 times x. So I will be worrying about that argument, which is pi over 2 times x, and it's going to be, well, same exact number of steps that we performed for the sines and cosines. So I just need to put this argument of function tangent in between of not 0 and pi, but negative pi over 2 and positive pi over 2. That's the idea of graphing those functions with so-called asymptotes. So I'm going to need to see what happens with these asymptotes if I isolate letter x by taking the reciprocal of that pi over 2, so it'd be 2 over pi. So that way, all I have in the middle is just letter x, and that's my goal. So goal is always to isolate x. On the right side, I'm going to get +1, on the left side, -1. So instead of having 2 vertical asymptotes at pi's over 2 with a plus and a minus sign, now I'm going to have those asymptotes at a -1 and a +1. So that's the key part for all of these graphings. So after I'm done with this, I'm going to have the function tangent graph that goes upwards. It's like a cubic parabola, and downwards in here, and repeat a little bit to the left and to the right. So that's how we have this produced. Again, the graph is having only pi as a period, not 2 pi in the original case. And then we just want to isolate x in the center, and that will take care of it. So graphing tangents, they have those vertical asymptotes. I just saw another one here, exercise number 37. So I'm gonna graph without that -2, because with a -2, I'm gonna just bring the whole picture down. So my goal will be to take a half and multiply it by tangent of that argument, which is 1/4 x. So what happens with a graph if you multiply it by 1/2? Well, if you recall how this happens with, say, graph of parabola x squared, then its shape is not really changing much, but distances to the x-axis get taken a half of. So if you multiply by 1/2, then if you used to have distance from point to the point on the parabola to x-axis, now we break it into 2 equal pieces. But the shape of our graph is not really changing. So I'm gonna just care about this 1/4 x. I'm gonna put it in between of these new 2 boundaries, minus and plus pi over 2. That's for tangent. That's something to, well, I guess remember, or if you don't want to remember, it's okay. You could just write it down. So I'm going to multiply by 4, because this way the denominator 4 is going to cancel, right? So we get x in the middle. So on the right side, I'm going to get, looks like 2 with a pi, and analogous but negative 2 pi will be on the left side. All right, so the graph of function tangent. I will, again, use just one little period, and analogously to the previous example, just have it going upwards and downwards, like that. So that 1/2 is not really playing much difference in terms of the graph, because it's still the same shape, but my asymptotes now happen to be 2 pi and -2 pi. And then the final step. Now I need to go with the -2. So I need to bring this whole picture 2 units down, right? So let us have this point at -2. Now I already know how my vertical asymptotes are going to look like. So I put this minus and plus 2 pi's, right? And then we get the actual graph that goes upwards from that point and then downwards. And similarly on the other side, here's downwards and upwards. So I would say for people that want to take calculus 1 and 2 classes, this is definitely what you want to look at again over weekend. And if this is your terminal class, then I'm glad that you just saw function tangent, its graph, and that should be good enough. Turns out that tangent has its little friend cotangent or reciprocal, and today I don't want to give you a quiz on this because there are too many graphs, too much information. I'll just graph cotangent for you, and I think that should be good enough for today, because the graph of function cotangent is similar, but notice it's vertical asymptotes now at multiples of pi, and the actual graph goes down. So it goes down. So if I get this one piece in between of 0 and pi, and then repeat it to the left and to the right, I will get the whole picture. So we just care about, again, like a main wave or piece of that cotangent function. Once I be able to put it in between 0 and pi, then I should be able to graph the whole thing. So I will select one graph with a cotangent and give you that, and that should be good enough for today. Don't want to overwhelm you with these others. There's also secants, cosecants, so that's for the next time. So I saw cotangent in exercise number 24. So let us try to do this. In this exercise, I have y is equal to cotangent of pi over 4 times x. So I guess the whole point of this story is to show you that pattern is the same no matter you have a tangent or sine or whatever else. You just need to put it in between of those boundaries. And for function cotangent, I should write it carefully, cotangent, it's 0 to pi. And then we're going to, as usual, pull out x, right? So I need to put 4 on the top and pi on the bottom. Same here, 4 over pi, and then another 4 over pi on the left side. So 0 will be on the left, and then x is in the middle, and all I care about is what's on the right side, and this is going to be number 4. And this is great. So now I'm ready to make a picture of function cotangent that has 4 as its period. 4, and then if you want, you can put another 4, which is 8, and so forth. So the graph of function cotangent is falling down. So starts on the left and goes down on the right side. It looks somehow like that. And you can also put, if you want, another branch here. That's gonna look nicer. So we just graphed function cotangent of pi over 4x. So again, the key part is to look at this periodic piece, and that will tell you everything you really need for your graph, just like on the picture that I have here for you once again. So graphing functions tangent and cotangent is an idea for today, and next time I will show you the other two, secant and cosecant, because I think it'd be a little bit too much if I throw so many graphs at you at the time. In fact, we already had a quiz last time, and I think it's enough for you for this week, right? You deserve a break. need to have a little break from this, and I think on Tuesday next week I will continue with this section. So I don't give you any quizzes today. I just let you go without it. I'm gonna stop to record, and I hope that over weekend you will